Now that summer is winding down and you've already spent lots of time in the water, I want to show you now how to figure out how much pee is in any pool. There's actually a lot of misinformation on the topic of pee in pools, so I'm going to do some experiments on my own, along with some clever science people in foreign lands, and spoiler alert, some of the results are good news and some aren't. So let's jump right in. So this first experiment is to determine how much pee is in an actual sample of pool water using an ingenious method.
So I got two samples from my friend's community pool where lots of people swim, one from the pool and one from the spa. And then two samples from a friend's backyard, again one from the pool and one from the spa. I also collected samples from the source water at each location as a control, and I'll explain why in a minute. Now that I have my samples, I needed to quickly get to my scientist friend Lindsay in Canada, but lucky for me, I knew a shortcut.
We are now in the lab of the University of Alberta, and this is Lindsay Blackstock, and she is basically a genius. So you are going to help me determine how much pee is in these samples, because we know people pee in the pool.
Yes, we have strong evidence that people do pee in the pool. So we're going to try to find a way that we can measure that pee without actually measuring pee. I'm going to apply my new strategy based on the amount of artificial sweetener that's in the pool. We know artificial sweeteners don't come from anywhere except for urine. So that's the only logical source for them. If we find them in the pool and we know how much artificial sweetener is in the average person's pee,
Right.
and then using that, we can estimate how much pee is in the pool.
Got it.
So we're gonna take this sample, we're gonna bring it over to our sample prep bench.
Okay.
We're gonna filter it, transfer it into some special vials, into this instrument, which is a liquid chromatography system.
Of course.
So this instrument is going to concentrate our sample before it passes it on over to the second instrument, which is a mass spectrometer. And the mass spectrometer is able to detect the individual little artificial sweetener molecules one by one.
Love it. Let's get to work.
Bring it on over there.
Before we run the samples, let me explain why I find Lindsay the scientist's solution so brilliant. You can actually take a sample of pool water and directly measure the amount of urea in there. But the problem with that is humans also excrete urea through things like sweat, which is also very common in a pool. So you can't tell how much of that urea actually came from pee. To get around that, she looked at the amount of a certain artificial sweetener in the sample called asulfane potassium, which is really common in food products such as these, oh, and also all of these. So pretty much everything. The reason drinks like these are 0 calories is because you taste the asulfane potassium sweetener, but the chemical compounds aren't broken down at all by your body. So more than 99% is passed through in your pee within 24 hours. And therefore the only reason this would be in the pool is if it passed through a person first. And just to be sure, we measured the source water at both locations, because sometimes trace amounts of the sweetener can be found in the water supply, and if so, we just subtract that from the results. And I love this, because we've all wondered how much pee is in a specific pool. But Lindsay figured out a really clever way to use proven science to actually answer the question. The mass spectrometer takes about an hour to get results, so while we were waiting, Lindsay told me something that really surprised me. Chlorine in pools is obviously really helpful because it breaks down harmful bacteria, viruses, and microbes that would be harmful or even potentially deadly to humans. However, there is one big downside, and that is it reacts with urine to create a byproduct called trichloramine.
So trichloramine is what's responsible for that chlorine smell that you might get when you enter into an indoor swimming facility. It's
But
also,
if I just smell chlorine, like straight out of the bottle, it kind of has that chlorine-y smell to it.
yeah, but the smell that you smell in a pool is trichloramine. Like this is the compound responsible for that characteristic swimming pool smell.
And if I look skeptical here, it's only because I was. So I devised an experiment of my own to see if this was really true. For the experiment, I got 2 5-gallon buckets and filled them with pure water. Then I added 4 times the recommended concentration of chlorine for that volume of water to both buckets. And then only in the bucket labeled B, I added just a little bit of P. And then I let it sit for a couple days.
All right, so it's been 3 days, so this is the moment of truth. So the first thing I notice is visually they look the same. You can't tell one bucket from the other as far as color of water goes. So I'm gonna start and smell this one first. So that doesn't smell like anything. That smells just like water, even though this has 4 times the recommended concentration of chlorine for this volume, which makes me nervous to smell this one. What? That is crazy. This smells like a pool, even though the only difference between these two is this has a little bit of pee in it. This is a nostalgic smell. This smells like summers and vacationing at hotels with pools and water parks. Turns out it was just pee. So if trichloramine, which again is what is produced when pee reacts with chlorine, was just that classic pool smell, that's not that big of a deal. But the problem is, it's kind of bad news for both your lungs and your eyes. When your eyes are really red after swimming for a while, that's actually because of the trichloramine from the pee, not the chlorine. Trichloramine also causes things like asthma. In fact, studies show asthma is more likely to occur among elite swimmers than any other high-level athlete. Which now makes sense because Michael Phelps admitted to always peeing in the pool, and he says all his buddies do too. So be cool and don't pee in the pool. Now let's go see Lindsay's results. In Lindsay's research, she sampled 20 public swimming pools and 10 public hot tubs. The average concentration of sweetener for the pools was 470 nanograms per liter, and for the hot tubs was 2,247. So after running all of my samples, we found that here in my friend's backyard pool, they had a concentration of artificial sweetener of 69 nanograms per liter, which equates to just under a gallon of pee, which is actually much lower than the average, but that makes sense because this would see much less use than a public pool. Their spa had a higher concentration than the pool at 103, but since a spa contains much less volume, that equates to about this much pee. So far, not bad. And then in this public community pool, we had 27 nanograms per liter of artificial sweetener concentration, which for this volume is again a little bit less than a gallon. And then the spa was higher at a concentration of 335, which is about this much for the volume of the spa. So the concentration of artificial sweetener in this pool and spa is much, much lower than the averages Lindsay saw in the 30 samples she collected, which leads me to believe that the water has been completely replaced recently, which happens from time to time for various reasons. If this pool had the average concentrations reported by Lindsay, for these volumes, we would expect to see over a gallon of pee in the hot tub and about 13 gallons in the pool. If you want an estimate of the pee in your own pool, I came up with a simple equation after talking with Professor Ernest Blatchley of Purdue University, who mentioned that studies have found that swimmers introduce between 25 and 80 milliliters of urine per swim session. So you take the average number of swimmers that were in your pool per day during the summer, and then you multiply that by 1.2. That's how many gallons of pee are in your pool at the end of the summer. And if you think your friends and neighbors pee more than average, use 2 as the multiplier. And if you think they are more on the courteous side of the range, use 1/2 as the multiplier. As a general rule of thumb though, public pools about this size will contain approximately 13 gallons of pee, and Olympic pools will contain, brace yourself, over 130 gallons. There are some caveats to these generalizations, so check out the links in the video description for published papers from both scientist Lindsay and Professor Blatchley. So in conclusion, what does this all mean? Like, is this something to be grossed out about? For starters, let me just say pee is generally considered to be sterile, meaning it's free from bacteria and any living things. You could totally drink the stuff and not get sick. In fact, in some cultures, that's totally a thing.
You drink the grandson's pee and it's gonna help you.
Additionally, urine is made of 95% water and just 5% of dissolved solids like the urea stuff we've been talking about. The fact that pee is so dilute at 95% pure water is in part, disappointingly, why it's really hard to make a chemical you could add to any pool that will magically turn blue if someone pees in it. Having said that, I suppose it's still a little gross knowing you're swimming in even just a small amount of pee, but I feel the benefits to your happiness and well-being that can come from swimming far outweigh any sort of gross factor or minor health risks. I guess at the end of the day, my advice would be to be cool and don't be in the pool. And then at that point,
Just keep swimming, just keep swimming, just keep swimming, swimming, swimming.
Just maybe take a shower when you're done.